Hello guys and gals, and welcome back to our videos on Unit 5 on kinetics. In the last video, we talked about collision theory and elementary versus complex reactions. In this video, we're going to be looking at 5.5c, in which we're going to be talking about how Maxwell-Boltzmann distribution curves can be used to help us talk about kinetics. So we've used Maxwell-Boltzmann distributions before, but usually we've just been using them to talk about the behavior of ideal gases when we increase or decrease temperatures and kinetic energy of our particles that are usually gases, right? But we can also use Maxwell-Boltzmann to help us talk about the fraction of particles that actually have the energy necessary for a reaction to occur. And we can also we can use Maxwell-Boltzmann distributions to talk about how changing the temperature would help us increase the number of molecules that could react or decrease the number of molecules that could react, right? So again, in the last video, we talked about activation energy is the energy needed for a reaction to occur. It's the energy that the particles have to collide at in order for a reaction to occur. Hold on a second, for some reason it's being slow. Here we go. If we're given the activation energy, and we're given a Maxwell-Boltzmann distribution that has the x-axis labeled as kinetic energy, all we have to do is see how much of the curve falls past the activation energy point, right? So this is the example that we're looking at here, and we can see that the activation energy in this case is actually really high. Because remember, the further we go to the right, the higher our energy gets, okay? We're talking about speed, that also means the higher the speed gets, the faster it's going. So in this case, we're talking about energy, and our activation energy is pretty high on our energy scale. While the majority of our molecules, their energy is not there yet, right? The majority of these molecules have a lower energy than they need in order for reaction to occur. So if we were using this curve to talk about the fraction of molecules that have the energy needed to make the reaction occur, it's very low. There's a very low fraction of molecules that could actually react right now. And so when this happens, when we see a very low fraction of molecules with that activation energy that they actually need, what we're going to see is either this reaction is occurring very slowly, or in some cases, that fraction just might be so small that it's not even occurring at all, right? So this is a very slow reaction because the fraction of molecules that have the speed necessary for the reaction to occur is very, very small. Now, if we could somehow increase the energy of these particles, well, then more of the particles would have the energy that they needed to react, and so therefore the fraction would get higher. Now, there are several ways that we can increase energy, but the most common that we're going to talk about is temperature, right? We can increase the number of collisions. We can increase the energy by increasing temperature. Now you can do homework problems 3A. Sorry, that's the only one you can do after this section. It gets a little more complex past this point. But hopefully that helped us understand a little bit more about Maxwell-Boltzmann distributions and how they can help us look at activation energy. Let me know if you have any questions, guys.